Hey guys, hope you can hear me. Let me make sure that my volume is good. Let's see, testing. Can somebody indicate if they can hear me well? I want to make sure that my volume is very good. Um, let's see, because this is my device. This is reduce, increase volume. Let's see. Let's make sure it's on, that my volume is good. Let's see if we can have somebody who is joining. So I'll share on my Facebook page. Let me share on my Facebook page. All right. So I'm just sharing my class link here on Facebook. Thanks for joining. I see somebody has joined. Appreciate it. All right. So let's give it a moment for others to join. So I'll just share this. And I hope everyone is fine. I see two persons joining. Just comment to let me know that you can hear me. If you can hear me and see my screen, please comment and let me know if the volume is okay. If you can hear me and see my screen, please comment and let me know if the volume is okay. Okay. I don't know why it shares two times on YouTube. I don't know why it shares two times on YouTube. I don't know why it shares two times on YouTube. All right. Can you guys hear me? I think you can hear me. Sorry, I was on the device trying to make sure that the volume is fine. Okay, I see three persons have joined. There's one person watching on my page and one person watching from YouTube. Okay. All right, thanks, Anim. You can hear me. All right, appreciate it. Thank you for your comments. Really appreciate it. Please let's share this so that others can join us. This is going to be our second class for the week. Well, no, not for the week. This is like our second session, right? And last week we were looking at an introduction to advanced AI, and yeah, we covered that again. We went over what we did the previous week, and then we went to week 2, and we looked at decision making. Right. Today we're continuing with decision making, but we are no longer looking at search algorithms and adversarial search. We are looking at the process through which simple decisions are made, and we'll also look at utility theories and their models, right? So these are the things that we're going to explore today. Very interactive. We're going to make it as simple as possible. We're going to make it lively as well. So these are high concepts in AI, right? These are some of the concepts that are used in building AI models and tools and making decisions. How machines or how AI systems really make their decisions. So that's what we're looking at today. And if you have any questions on career, so I know the market is a little bit technical now in terms of, I mean the IT market, of course. The IT market is interesting now. Let me see if I can show comments on stage. Yes. So the IT market is a bit interesting now, given that people have been laying, like organizations have been laying people off, and that's okay so far as people have the skill sets that they can really jump back into the market. There are a lot of people who are laying off people due to the the overhiring that happened during COVID. People overhired, and then the impact after COVID when companies were trying to recover and all that has been the laying off of people, and the economy and all of that has affected the way organizations normally work, right? And that is balancing up as we speak. Companies are beginning to unfreeze from their hiring freezes. Companies are beginning to make moves when it comes to hiring decisions. I've been in about 4 interviews this week. I've interviewed 4 different candidates this week, which means that organizations are beginning to already gear up for hiring. And yeah, and before we go right in, if you have anything on how to get into IT, how to do your technical interviews, how to nail the job market and all that, please don't hesitate to ask. And getting started in IT may seem, really hard, but it's not that hard if you're determined, right? It's not that hard if you're determined to work hard. It's not for those who just want to test out and then leave. No, it's not a 6 months thing. You're done, and then you think that I'm getting the job immediate. No, you can do a 6 months training, and then you're consistent for a year, for 2 years before you learn your job. By that time, most people gave up, right? They're like, oh no, these guys scammed me or something. No, they didn't scam you. It's the process. You have to learn. You have to grow in it. You have to be consistent. You have to keep interviewing. You have to keep going, because that's what would land you the job. There are a lot of companies out there, a lot of hiring managers, a lot of people who are hiring people for different reasons, and definitely yours is coming. And so it's just a matter of consistency, right? All right, that was it for those who are in the market and trying to get in. Reach out if you have challenges in this space, and we can help you with that. All right. I think we have just 2 persons in. I think we can get started actually. Those who watch the video after, we don't want to keep them waiting. All right. So today, I want to talk about decision making, right? Simple decisions, and how AI is able to make decisions, right? And there are a few concepts that we'll see here. We'll hear about decision theory and its foundations, right? So, decision theory is a framework. It's like a formal framework. When they talk of a framework, it's like a template that organizations or people use, a template that is defined. That if you want to reach if you want to reach a decision, you can use that template to go through the process that is laid out in that template. So that's what a framework is. It's like, yeah, so decision theory is like a framework, or provides a framework for making rational choices or making rational decisions, choices or decisions, right? Under uncertainty. So when you're uncertain about a thing, under uncertainty, when you're uncertain about a thing, how do you arrive at a conclusion for that thing? So this theory combines probability, and probability is very, very big concept, and we're going to explore it today. So the theory combines probability and then with utility theory. These are different theories. Utility theory and probability are big theories that we're going to explore as as we go along, and it is very important that we understand this if we're going to understand how these decisions are made. And so probability, right, is basically like how likely something is. How likely is it that this thing would happen? That is basically how we can define probability in normal terms. How likely is it that it will rain today? You are uncertain, but you want to, you have some parameters that you're gauging, right? That's probability. How likely it is that something would happen. And then utility, on the other hand, right, is how much you like the result of something. That's utility. How much the results of something mean to you. Think of it this way. You don't know if it will rain, just from our example. That's uncertainty, right? You are in an uncertain situation. You can either carry an umbrella or not carry an umbrella. Those are actions that you can take, right? Should I carry an umbrella or should I not carry an umbrella? These are uncertain actions that you want to take, right? Based on that uncertainty that you have. And so getting wet versus staying dry, these are outcomes that can come from that decision that you make. Very important. So either you get wet or you stay dry. These are outcomes that result from the decision that you make from uncertainty. What's uncertainty? Whether it will rain or not. What are the actions that you can take to as uncertain actions? You can either carry an umbrella or not carry an umbrella. And what are the outcomes of the decisions or the actions that you take? The outcomes are, well, you can get wet or you will stay dry. So how likely is it that it will rain or not? That is probability. And how bad is it if you get wet? You see, that's utility. How bad is it if you get wet? That is utility. Utility measures how much you like the result of an action that you take. So decision theory, therefore, is basically a fancy way of saying that when you don't know what will happen, how do I choose a smart move? How do I make a smart option? Right? That's basically the utility theory. If you understand this theory, you're good to go. That's basically the utility theory right there. And that is how simple decisions are made in AI. All right, that's it. We can close it for today. If you understand this, we can close it for today. All right. Thank you very much. Greetings, dog. That's from You Can Be Anything podcast. Go and watch that podcast. It's amazing. Go and watch it, guys. You'll be, get a lot of smart things on there. She's amazing. So shout out to the You Can Be Anything podcast team. All right, thank you. All right, so if you understand these about decision theory, decision making in AI will be a simple thing for you. So there are a few terms that I've mentioned. I've mentioned actions, right? And we said actions are the available choices that a decision maker can take, right? So should I get an umbrella with me or not? Should I take an umbrella with me or not? That's an action that you're taking. So these are choices that are available to a decision maker. And these choices are available to the AI system as well. States, that's another component. States are the possible configurations of the world. They are the possible scenarios where you can be. And what are outcomes? Again, we already told you the outcomes in our rain example. What could an outcome be? An outcome could be that you're wet or you're dry. So they are the result of taking an action in a specific state. And what are utilities again? We already defined utilities. There's probabilities, which is the likelihood of different states occurring, the likelihood for something happening, the likelihood for it raining or not raining. Those are different states, whether it rains or not. their state. And then utilities, as we said, they are the numerical values representing preferences for outcome decision rules, or for preferences for outcomes. So we defined utilities as the degree to which you like the results of something. You could also put that in numerical terms, and it will be defined this way. Then there's what is called decision rules, which are simple approaches that decision making can take, right? So there are decision rules, and these are very important, right? And there are different approaches that you can use to make decisions. And in decision theory, there are multiple of these. There's what is called EU, expected utility. And you will see different types of utilities here. So expected utility maximization. This is a decision rule that you can take. And this decision rule simply means choosing the action with the highest expected utility. So you're choosing a decision with the highest expected utility. And we define utility as how much you like the result. So you're choosing something with the highest degree of you liking that thing. All right. And then there's what is called the maximin. This is another type of a decision rule. So see, decision rules, they are the rules that guide the decisions that you're making. So if we're understanding this, all right. Yeah, thank you very much. We see Kizita has joined. Thank you, appreciate it. I joined late. No problem. I think you're still on time. All right. So we're saying decision rules are like the rules of the game. They are the rules that guide that guide decision theory, right? That guide the decisions that you make. And we we said expected utility maximization is when you're choosing the action with the highest expected utility. You will see expected utility, will be abbreviating it with EU. In AI, they abbreviate it with EU. And then there's what is called the maximin. And with this decision rule, you're choosing the action with the best worst case outcome. So you're making a choice between worst cases, right? You want to choose the best worst case. So you're already found in the worst case, and so you want to choose the lesser evil in the worst case. So in this case, if we're bringing it in theological or philosophical terms, we will be talking about the devil, or the lesser evil. In this case, with St. Thomas Aquinas or St. Augustine, you're talking about the lesser evil in between evils. So say everything is evil, and you decide to choose the one that is not too bad. Say you're faced with knocking a building down and knocking a child down. Those are all negative outcomes, right? But you choose to knock the building down because the value of the building is less than the value of a life, of taking a life. And so, faced with two outcomes, you're choosing the best worst case. That is what maximin is all about. And what is maximax? Somebody can already guess from the maximin definition. Maximax would be then choosing the action with the best case outcome. So you have two best cases, and you're making a decision that favors the best option. So it's going to be the best case. This we don't need to explain this one more because we explained the opposite of it. And another decision rule is the minimax regret. And the minimax regret is when you're choosing the action that minimizes the maximum regret. You're choosing an action that minimizes. So your action has to reduce maximum regret. So say you're faced with a stock market decision, right? And the decision can either make you profit, or when you or make a lot of profits, right? Or when you're losing in the decision, you want to lose, you want to minimize the regret of the loss. You don't want to lose like 200 million. You want to lose 5,000 from your business decision instead of 200 million. And so with the minimax regret, you are choosing the action that minimizes you having a maximum regret. These are the decision rules. These are the rules that guide decision theory, right? And so if you've understood what probabilities are and what utilities are, with these rules, you are guided in decision making, and that's how AI systems are guided in the decisions that they make, right? All right, let's see if we have any questions here. No questions. If you have a question, guys, just comment it out and we should be able to get back to you. Even if you're watching after, please just add a comment and I should be able to get to it, whether you're watching from YouTube, from LinkedIn, or from Facebook, right? I should be able to get back to you with a response because I'll be watching that. The I'll be following up with the video on the various platforms. All right. Okay, guys, feel free to share this out for those who are AI enthusiasts or people who just want to learn about AI. Okay, so we're looking at decision theory, and we're going through the various components in decision theory, and we are trying to break the decision rules down. All right, so what is expected? The expected utility theory. The expected utility theory was developed by Norman and Morgenstern. These are big boys when it comes to the utility theory. They're the ones who kind of developed this theory. And of course, we've said it defines a framework for decision making under uncertainty. You're making a decision under uncertainty, and it's the same scenario where AI finds itself. AI has to make a decision. When you give it information, it has to walk through a decision process to be able to give you an output. And how should it get you the best output? The output that maximizes your best interest, the best case outcome, the best case outcome, the maximax. How does it get you that maximax, right? Right, is what decision the expected utility theory tries to do. And the theory states that a rational agent should choose the action that that maximizes expected utility. That's what the theory says. That the rational agent, a rational AI agent, or even you and me, we should choose the actions that maximize your expected utility. And remember what we said utility is? We said utility is how much you like the result. And so you want to maximize, your expected utility. And this is the formula that defines this framework. And expected utility here is, so this is the formula, expected utility. Remember I said it's abbreviated with expected utility of A. A is an action. A, which is the expected utility of an action. So I'm saying A is the action. So remember we defined an action up there. And we said an action is an available choice for the decision making. And so we're saying that the expected utility of an action, which is A, is equals to PS, right? Is equals to P of S. And P of S is the probability of a state. The probability of a state, we just define probability as that state of as an uncertain scenario where you find yourself, right? And so P of P of S is the probability of states, right? Represented by this S. That's what I was saying. The probability of S, the probability of a state. This is what this simply means. And it is times the utility. And the utility is equals to what? The utility of an action and a state. So the utility is the this part here. This part here is the utility of an outcome that is resulting from the actions in a given state. So in a given state. So a state, of course, is the scenario where you find yourself. The scenario where you find yourself, and there are different risk attitudes that people can take based off of the decisions that they are making. So individuals have different attitudes towards risk, for example, and those attitudes influence the risks that they are able to take, the risks that they're able to bear. That's why you hear somebody saying, hey, I'm a big risk taker when it comes to business. And someone will say, no, I don't have any risk tolerance, right? I don't have any risk tolerance, or my risk tolerance is very minimal, it's very low. And so, sorry, individuals have different attitudes towards risk taking. And these attitudes would affect their decision-making processes. So one risk attitude is called risk aversion. Risk aversion, from the text or from the words, you already know what this means. This is the preference for a sure outcome over a risky prospect with the same expected value. So in your decision making, you want to take the minimal risk, but you also want to take the risk because you want to get the output. This is what risk aversion means. So if you're a stock trader, you don't want to just sit and not trade. You want to trade, but you want the least risky trade. If you are a business person, you want to engage in business, but you want to evaluate the business to make sure that you're entering into a very risk-free type of business, but then also maximize your profit. Is what risk aversion is all about. So it is the preference for a sure outcome over a risky prospect with the same expected value. This leads to concave utility functions. So it leads to some type of functions that are developed. And then there's risk neutrality, and this is indifference between a sure outcome. So the sure outcome in this case is the positive outcome, right? And a risky prospect with the same expected value. So you're entering into something 50-50. You're entering into a scenario 50-50. You don't know whether it will work, it will not work, but you want to take that risk. So you have a risk neutral attitude. And then from risk taking, you already know what this is. So this is a preference for a risky prospect over a sure outcome with the same expected value. So in this case, you're expecting a value, a positive value, but then you're willing to take the risk. And if you're taking a risk, a higher risk, it means you're probably ready for either a very bad outcome or a very good outcome. And so it leads to certain types of functions that are defined called convex utility. And so understanding an agent's risk attitude is crucial for modeling their decision-making behavior. So if you understand the type of agent you want to build, it'll be easy to build a model that support the decision system for that type of agent. Same thing for human beings. If you understand your decision, your behavior, your attitude towards risk-taking, people are able to engage with you a lot when it comes to business decisions and business things, right? You're able to make good decisions or bad decisions. You know where to be when it comes to decision making. All right. Any questions? If you have a question, just let us know. So that's what really decision decision theory is all about. And this decision theory is applied in all aspects. I'll demonstrate the decision theory to you very soon, right? It's done in economics, finance, especially in the stock market, in trading, in crypto, in all the financial industries, healthcare industry. It's used there as well, and in robotics and all that. It's used in all these industries. And so let's perform a let's simulate a decision making process here, right? We want to carry out a decision making process in the stock market. And the scenario is that you want to make an investment decision. So you have a decision to make. You have $10,000 to invest. You can choose between stocks, which are high risk reward, or bonds. So you want to choose between stocks or bonds. And bonds are safer, but you would have lower returns for bonds. And the stock market performance depends on economic factors, the economic factors at that time. You see? So the stock market is risky. It depends on factors that are influencing the market at that time. And so you have a decision to make. Do you want to invest in bonds that are safe but have lower returns? Or do you want to invest in stocks that have higher risks because they're influenced by market performance and if the performance is bad, you are in a bad shape, a bad situation. Performance is good, you're in a good situation. And so this is a probability that you could take. You have a probability of a good market. The stock returns in a good market. This is what they will return. So if the probability of a good market is 60%, you probably want to be in the stocks. And then the stock losses in a bad market. This is how much you will lose in a bad market. And your risk tolerance. Say your risk tolerance is risk seeking. You're 50-50. You can either invest in one or the other. This is where these things are. So you can draw them up or down, right? You can bring them up or down to make, to measure how much the output would look like. So this is a decision analysis we want to make. So we have this in stocks and 5,000 in bonds. And 5,000 in bonds or 5,800 in stocks, 5,000 in bonds. This is utility theory and it's expected monetary value. So let's try this and make a decision. So based on your risk tolerance and expectations, you should invest in stocks in this case. But let's try choosing stocks based on this expected value. So in this scenario, you earned $15,000, right? But then let's make another scenario and choose bonds where your expected utility is 5,000 bonds, 5,800 stocks. So let's try this. So if you choose stocks, see the results you get. Oh, if you choose bonds, sorry, it's a bad day. Your return is 5,000 for bonds. But if you were to choose stocks, you would have probably made 15K in that scenario. So let's make a new simulation and maybe change this. You see, let's do a probability, a bad probability. Probability of good market is that. And then let's say your stock return is this, and stock losses is that. No, let's say stock losses will increase. And your risk tolerance, let's say your risk tolerance is higher, is 80%. So in a scenario like this thing is advising you to choose bonds. But if you choose stocks, what happens? you earned 17,000. You earned 17,000. Why? Your risk tolerance is high. The probability of a good market is 40%. And then the stock returns is good. You see? And your probabilities, like the market favored you because of the conditions, because it depended on the performance of the market. So it turns out conditions were good. And so you chose a risky venture. You see, your risk tolerance is very high, and your outcome, $17,000. All right. But if you choose bonds, in this scenario and run, well, you're good, but you earn less, which is 5,000. Still good. You're still in a good situation, but your risk tolerance is high. You should have chosen the stock. So you can play around with these simulations for yourself, and play with it and see what it does. And this is basically the code implementation. I will share the code implementation here. So let me share my screen on my notebook so that I explain the code implementation of this. So I'll have to stop sharing and share the other screen. So share screen. I want to share screen, and I want to select my notepad, which is this one. So it is the same code implementation as I just showed you on the other side. Right? This is basically it right here. And what does this do? This is basically a the implementation of a decision problem, right? So the first thing there, which is NumPy, is just importing NumPy, and it's used for different things like calculations and all that, right? So remember, it's what we call libraries. We import it. So we're importing NumPy because we are going to make some calculations, right? All right, and then we have the class, which is called the decision problem. So this class right here is called the decision problem. And NumPy is this one. So this class is decision problem. And so in the decision problem, you want to initialize it. You want to store the various states, right? You want to store the various things. So the actions, the states, the outcomes, and the probabilities. You want to store them in the object. So it will initialize the decision problem. And these are the various parameters that you have. So actions are a list. So a list of actions that you can take. And then you have states, which are a list, possible states, and so on and so forth. And then you're simply just defining them and storing them here so that other modules can call them. I will not be teaching Python here, but I'll just be explaining high level. And then here is a method, and this method is called the expected utility method, and it's simply doing the calculation of the expected utility for the actions that you'll be taking, right? And that's your expected utility. And so for this, it is just the various actions that you're taking. So we're defining it using the actions there, and the choices that you can make, right? You can either bring an umbrella or not bring an umbrella. Remember, in the rain scenario. And then for the states, would it rain, will it not rain, and so on and so forth. And then outcomes for each action or state or pair, what is going to happen. If you bring an umbrella and it rains, what's the outcome? And then possibilities, of course, is how you like it, right? And then the init here is just storing the output, right? Just like the others. And then best actions, this is the utility function that we talked about. Remember, we talked about a utility function, and it gives you the best action that you can take. So this function you decided to use a utility function in this case. Remember when we're talking about the risk attitudes, and the types of attitude that you take would determine what type of functions you can use to build your model for the agent. And that's just what we're using here. And if you execute this, it gives you this output here, where your best action is no umbrella, and your expected utility is this and that, and then the maximum is this. The maximum, the minimax regret is no umbrella, and the utility is 70. I don't want to go into details because this is going to confuse a lot of people. We are not doing Python here, so let me start sharing my screen and go back to the other screen, which is this one. So this is the implementation. You can play around with it if you want. And then documentation, you can just read more about decisions and so on and so forth. All right, so let's see if we have any questions here. No questions. All right, there are no questions. All right, let's take a pause and see. Is it going well for those who are listening? Let me know what you think. Let me know what you think about decision making. How do you make a decision yourself? How do you guys arrive at your decisions? Do you reason it out? Do you arrive at a decision just randomly? How do you make a decision? So Valentine is asking how he can access the tool you're using. So the tool I'm using is this. Basically, just go to my. This is just a website. Are you asking about this or the environment I'm using? So you're asking about the Jupyter environment or just this this URL. I sent the URL to the website. So if you're asking about Valentine, if you can clarify, are you asking about Jupyter Notebook or the? Okay, wanted to ask about the tool as well. Yeah. So I'm using Jupyter Notebook to run this. So Jupyter Notebook, you can download it. So if you go to Google and just type Jupyter Notebook, it can bring you to a web version of it. So let me share my screen to this. So if I share my screen to this new tab here, what we're going to do is, if you just type Jupyter Notebook, all right, you can decide to use this version, the web version, right? You can decide to use the web version and just try it on a browser, or you install it, right? You install a Jupyter Lab on your system. So if you try it on a browser like this, right, and just choose this one, Jupyter Lab, it will open up a Jupyter Notebook environment to you, just like this tool, and you can run Python on here, right? Run anything you have, right? So this is mostly for those who do a lot of data science. So if I copy that code that I had on the other side, right, and just bring it in here and put it here and run, it will execute and give me the output, because this is a made up environment. It has all the tools that you require, right? So you see, I brought up the code. It's able to run in an already ready environment. So it's an already prepared environment. And then the tool, the small utility that I did is on the website. Do you say Jupyter Notebook? Yes, that's Jupyter Notebook. Does it support Apex? I think Apex, let me see if it's Jupyter Notebook supports Apex. Let's see. let's see. Jupyter Notebook does not natively support Apex code as a primary programming language. However, developers can interact with Salesforce data and the Apex environment using Python libraries with Jupyter Notebook. Yeah, so you can pull up the Python libraries for Apex, and you should be able. Jupyter Notebook is mostly Python for Python code, and so if you have to use Apex, you'd have to then pull Jupyter Python libraries for Apex to be able to run it within the Jupyter Notebook environment, and so you could do that. So there's an NVIDIA Apex that you can use. That's a there's Salesforce Apex and NVIDIA Apex. These are different ones that you can use within PyTorch, and it has a PyTorch extension, and you can use it within that platform. And then Salesforce Apex you can directly run Salesforce Apex code within a standard Jupyter Notebook cell, like you would Python or R. So yes, it's possible to do that, but you need to call those modules or libraries. Python or R, Salesforce development is typically done using dedicated tools like Visual Studio Code with the Visual. Yeah. So you can do that. I think you can do that. Yeah, Python is interesting. It's the most simple language, right? So you use VS Code. So I wanted to just check it out. Yeah. VS Code is very good and friendly, but then if you have to use these libraries like the NumPys, and install all the libraries like PyTorches, the different data science packages out there, it will be difficult to run them on your local. So or any environment, not typical Visual Studio environment. So you could another thing you could do is install Anaconda. Anaconda brings with it already Jupyter Notebook and nearly a lot of things. So Anaconda is this one. Let me share. So if I go here, you could do this one, Anaconda. If you install Anaconda, yeah, so this tool here. So if you go to this, all right, and download it. So you want to download, let's see. So you see it has all these things. You want to download this one. Let's see. So let me just type download Anaconda. It will take you directly. Should I go to download Anaconda, installing Anaconda distribution? It should be here. Download. Where's downloads? Download. Where are you? Okay. So you can see how much download is done. This is Anaconda, what I want. Oh yeah, I think you can install it from, okay, download Anaconda right here. All right, so this is it. You can download for free and install, and then run it from your local. Once you install it, you open it up, it will then bring up different tools. You have different tools, and it's very good now. You have different tools, and you can run Jupyter Notebook locally from there. So if you bring up, if you type Jupyter Notebook, Anaconda brings with it a lot of packages and tools. So once you download it, you will need to select Jupyter Notebook and just hit install. It just automatically installs it, and then Jupyter Notebook becomes available in your system. If you want to start it, you just type Jupyter Notebook, and it will come up, and you click on it. It will automatically open it up in your default browser. It will open it up in your default browser. If your default browser is Chrome, it will open it on Chrome. If your default browser is Edge, it will open it on Edge, and then you can have the same Jupyter Notebook environment. That's what I did, and that's why you see mine was on localhost, because I run it locally on my machine. And so you're able to run stuff and store it in your the advantage with that is that you can run code and store it in your local system, and run stuff and store it in your local system without having to deal with any other external stuff. All right, you can be at anything podcast used in Memo app. It helps a lot on learning Python. Yay, that is a dean. Yeah, thank you, is a dean. You know, Python is very easy to learn, especially now with AI helping. You can just ask AI to teach you Python. It will go step by step, and it is you get used to it as as you practice, right? As you go over it over and over. Does one need to master Python to get mastery of AI? Yes, Python is very important in AI, but it do, if you're going to succeed in AI in terms of actual developing models, yes, you need Python. Python is very important when it comes to data processing, because AI has to deal with a lot of information. You process a lot of data, and you mine a lot of data. You get to clean up a lot of data. You get to train models on a lot of data. So you should be able to pull this data from different sources, and you're pulling that using tools like Python, right? Should be able to pull that data from different sources, and probably store it in different locations. So you'll probably be pulling it from say, sources like databases or data stores or data lakes or CSV files or data warehouses or different platforms. So you pull data. This may bring us to another huge discussion about big data, data engineering, and databases and all that. So, the data today, I love data. Data is a huge, big deal today. And data is coming in today in different varieties, in different forms, in different shapes. In big data, you'll be hearing about volume, variety, and the five V's. In big data, you hear about the five V's. So if you just type the five V's in big data, the five V's in big data, you hear a lot about it, right? You hear about the volume of data, the velocity of data, the variety of data, the veracity of data, and the value of data. And these all describe what big data is really about. So what is the volume? The volume is how much data that comes in, how much data that is generated today. This is a video I'm doing here. Imagine the number of people who are doing videos right now, the number of people who are tweeting right now, the number of people who are texting, who are sending information out. Where do you think that information is stored? As I always say, you can generate the data that is generated in 1 hour today. In the past, or like that's data that will be generated in a century years ago, right? In a century years ago. So data that is generated today through devices, different types of devices. So now you could go into IoT devices, because Internet of Things is a big, huge deal now because of the prevalence of internet. Anybody has access to devices, to digital systems, and so they're able to generate and store information in different systems. And this data is stored in systems that are out there, and organizations are able to pull that data and make meaning out of it. And so pulling that data, right, from those sources is what we are saying that you're mining. You're getting that data and getting information out of it. Right? You're pulling that data, and you could be pulling it from different sources in its different varieties. That's another V in big data. So data comes in as audio, as video, as CSV, Parquet, as the different formats out there, the different file types, the different text, different formats. You're texting somebody in text format. You're sending a video. You're making a call on an audio, a video, or data comes in different varieties today. And so organizations have to to be able to get that data in that variety and make meaning out of it. And so when you get this data, if it's video and your organization is dealing with video data, you see you'll be developing models that can translate or process that video. Imagine what you can do with a video. You can cut it, you can slice it, you can look at shapes, you can label it, you can do different things. And AI will give you different things. So if you want to be in an industry that is just about video processing and image recognition and labeling and all, there's a whole world of, I work in an image labeling company, and it deals only with labeling data. So you get a video like the video we're doing here, and you do different things with it, or you get any video out there, or cameras are getting videos, and as the video is flowing in, as the data is flowing in, there is modeling happening on it, there is recognition of images. Maybe you're dealing only with image recognition, you want to recognize whatever is in that video, as cameras are capturing them, right? And those are used for different things. It's used in cybersecurity, it's used in police work, it's used in, and so on and so forth. So if you want to do that, you need to learn how to process that information through Python and stuff. Because a lot of open source tools and libraries and helper tools, you could build them yourselves, but today you don't have to build anything yourself. You have to use helper tools. There are a lot of helper tools that have been built that really are heavy in them, that you just use them. You just use them. Doc, you're slowly making me think of going back to school to finally do a PhD in big. Absolutely, and I know you have the energy, you have the drive, you have the zeal. Go for it. Go do a PhD in big data. We need more. We need more people in the big data space. Big data, it's wonderful. Like the value of data today, the value of information of data, it's just raw data when it's not processed. And so for us to make meaning out of it, it has to be processed. And when it is processed, it becomes information. It's just the raw thing out there. But when it's processed, it makes meaning. You can see a random video that is showing streets and so on and so forth. But you know how much companies are making from that video because they are able to use it and add it to its stack of training data sets that trains models about identifying stuff, recognizing stuff, right? And so they can use your video, they can use your data to process it and make a lot of money out of it. Thanks, Cornelia. Cornelia says so true. Absolutely. Big data it's everything. So data is the modern gold today, right? And so the data comes in different varieties, different shapes, different forms, and the velocity, the speed at which it takes to get in is amazing, right? And so that's really just big data. And so you need Python to be able to, get this data from different sources, extract the data. So I used to work as an ETL developer. in the past, I worked as a business intelligence developer and an ETL developer. So in ETL, it's all about extraction, transformation, or you're transcribing the data, transforming the data, you're cleaning the data, and then you're loading the data somewhere. So you extract data. So ETL or ELT, most people have been saying it's ELT. You extract data from a source, from a data source, and you have to define your data sources very well. And then you load that data somewhere. You're loading the data either into a database or into a data warehouse or into a data store somewhere. Let's just call it stores today because there are different database types today or data storages today. You can store it in a data lake and you start hearing of, and cloud computing is what has made this a big, big, big thing, guys. Cloud computing has made this a big thing. And that's why you hear a lot of people want to learn about cloud computing. Why? Because it is where you can store that data, you can process that data, and you can make meaning out of that data. It gives you the computing power. It gives you the ability to test things out, to process that data in systems that are really, really robust, right? And you can compete with big organizations. Whether you're a startup, you can compete with big organizations when it comes to processing information, when it comes to using readily available tools. Yes, it was a lot of work, right? Like ETL processes in the past was a lot of it was a lot of work, right? So you have to extract the data, and the data in the past was very redundant. The data was so unclean. You had to do data cleansing, a lot of data cleansing. You get data that is full of repetition. It's full of tables that are not useful. It's full of a lot of information that need work. And so, as an ETL developer or an ELT developer, you have to get that data from its source. You have data from different sources based on your organization. For example, if you're in education, in higher education, you will be working with data of students and teachers. So you'll be dealing with data about students, teachers, parents, and that type of data. So you see, you can decide to to grow your career in a particular space, and that's why when you're interviewing as somebody who just did your 6 months course, it will sound like some theory for somebody who is in the industry, who's been working there for long. Why? Because you'll be talking, just in the air, but the person understands that you have to work in a particular industry. And so if you're talking about, hey, I worked in higher education, you have to go down to the weeds. What kind of higher education are you talking about, right? So if you're working in university systems, when you're interviewing, you'll be talking with use cases that bear university systems in it. So you'll be talking about sorry, I'm diverging and going into different things, but it's important, right? You'll be talking about student data, how you were able to deal with student information, how you were able to transform student information if you are interviewing for an ETL process, and the type of systems that you're able to use to load that data. You can, in an interview, you can just walk an interviewer through an ETL process that you build. And today, ETL processes have transformed into pipelines. Now we're coming back to DevOps. You see where everything is just merging into one. Everything is just converging into one. You see, ETL processes today are DevOps processes, DevOps pipelines that you can build. And so you hear a lot about MLOps today. What is MLOps? MLOps is just building machine learning models and deploying them through DevOps pipelines, and use pipelines that are automated. And so data comes in, it is cleaned through models, it is modeled, processed, and automatically deployed into wherever you have to deploy it. The deployment is an umbrella term because deployment means a lot of things. You could be deploying traditional applications, or you're deploying very remote systems. So you could deploy a data pipeline to a data store. That's a deployment. Or you could deploy a software to the market. That's a traditional deployment. You could deploy a monolithic application. You could deploy a what type of application, right? So there are different ways that you could deploy things. And it comes back to DevOps. And so today, if you're an ETL developer, you want to learn more skills about DevOps, because ETL is evolving. You want to be in a space where you are somewhere between a DevOps engineer in the data space. So you be an MLOps engineer. You want to be in that space. That's where you want to be today if you are an ETL developer. If you're a business intelligence developer, you want to move towards data engineering. You want to be in that type of space where you are dealing with data extraction, data transformation, and data loading. Now you want to be in a space where you can actually data science, data engineer, you can transform that data using the models that are out there today, and you can make a lot of meaning out of it. And those are high paying positions today. And that's why when we're talking about making career decisions. You're making career decisions based on where the market is. And when we talk of where the market is, we're referencing the situation of tools, the situation of organizations, how they use different helper tools to make decisions. And so you need tools like the Python that we just mentioned to be able to do that. Good work, Doctor. Thank you, Virgo Potens. You're connecting from YouTube, and you can be anything. Podcast says this is encouraging. Thank you. Of course, I know you would do it. Go for it, and it's lovely. It's lovely, and the world of big data is crazy. So, what's the best route to certify in data analysis, etc.? So, there is a difference between. So, when I'm advising people, I tell them most AI tools today can do data analysis for you, right? But can do data analysis. Remember, there's a difference between data engineering, data science, and just basic data analysis. Data analysis today, or traditional, okay, let's put it this way. There's a difference between traditional data analysis and, data analysis today. Traditional data analysis, you take a data set, could be CSV files that are stored somewhere in S3 or in a local database somewhere, or files that are information that is stored in a database, right? Get that information from a source, and you perform, you put it into a system, you load it into a system like Tableau. These are already built systems with you have to understand what is behind. I don't like using a tool and I don't understand the logic behind the tool. You have to understand the logic that is built, the engine that is built on Tableau, the engine that is built on, what's the other tool? Tableau, you have Tableau, Power BI, and so many others, and IBM's, whatever. There are different tools that you use for data analysis, right? You have to understand the engine behind it. The engine behind it is just a bunch of code that is pre-built. It's like templates. It's like a way something has been packaged. It's pre-built, and it's able to get information. You drag and drop through a graphical user interface. You drag and drop that information, and you're able to change it into different formats. And you're able to populate it to give you different flares, different visual looks, right? And so traditional data analysis would just be getting that data from wherever it's stored, getting it into those systems like Tableau and Power BI and all that, and then making meaning. The analysis part is crucial, and that's why some people are crucial. You can't just get data analysts out, because they make meaning out of the data. You see data set, and the important thing is not pulling the data. The important thing is not dragging it and making it look beautiful. That's not the important thing. It is making meaning out of that data. First of all, to make meaning out of it, it has to be clean. So we need people who are able to say, hey, this column and this column makes meaning. It matches this date, bam, bam, bam. And in the organization, it has to be real data. Else it's just garbage, right? And so data analysis today is heading towards that place where you can literally just pull data from here and ask a tool or AI system or whatever to transform it to do calculations for you. You have to verify that the calculations are right, and then you make meaning out of it, and you're able to share it with stakeholders. It's summarized in one page or in 2 pages or in a slideshow. That's what leadership needs. And so data analysis sits somewhere between the data source and the decision maker, right? So if you want to be in that space, you need to upgrade the skills. You have to be going towards the Pythons, because a lot of Python is used today, and a lot of different libraries hub in data analysis. And then you have to learn cloud tools. You hear of QuickSight in AWS. Most organizations are beginning to store their data in AWS and use AWS native tools to clean that data, or store their data in cloud platforms and use cloud native tools. You will hear, if you're in the Azure space, you hear a lot about the data factory and so on and so forth, and use the data within that native environment to clean up data. And so you want to learn data analytics tools that are modern, right? You want to learn those data analytic tools that are modern. And so if you are in the AWS space, you'll be hearing about QuickSight. You can use QuickSight to clean data, get data from different sources, whether it's Redshift or the RDS or different location S3 in AWS, and transform that data. And you can use transformative tools in AWS like EMR, Elastic Map Reduce. Elastic Map Reduce is a tool that AWS offers, which has huge potentials. You can build a cluster of compute environments and you use it. AWS offers different tools. There's what they call batch, which is a compute tool. It uses, behind the hood, it uses EC2 instances, virtual machines, to process, as the power to process different jobs that you run, different ETL jobs. And this is used a lot within the insurance space. I worked also in the insurance space, and they do a lot of data engineering, a lot of data transformation, a lot of data work, because it's all figures. It's all figures. They are all punching figures and making insurance and trading world. So it's a big world. So that's where you want to be, Valentine. You want to navigate towards those environments. And if you position yourself there, you are no longer a data analyst. Your name, your title begins to change. You give yourself value in the market. Trust me, if you leave from that term data analyst to a data architect, an AWS data architect, your value automatically changes in the market. And how do you change your title? It's working on those tools, or an Azure data architect. It automatically changes. So if you are in that space of data analysis, these are areas where you want to head towards. Very important areas. And if you're already in that space, then you want to be transforming yourself to, a data engineer, data scientist, an AI engineer, right? Like an AI data engineer or something. You can already transform and give yourself a new title by just continuing to work on whatever you're working on. But you need to know like where AI is going, where IT in general is going, because there are a lot of things that were already traditional things that were done that are changing. And so organizations are getting rid of people, because right now, any organization I work with, AI is just everywhere. Use AI in coding, and they're expecting your output now to be higher than it used to be. Why? Because you have the tools. The organizations that have ChatGPT, they have uh, um, Windsurf, they have all the tools available, right? And in ChatGPT, they would have different models. There are some that use coding environments, and there are different coding environments out there. And the coding environments bring with them different models. They'll bring different models from Claude, from ChatGPT, from Gemini, from these different platforms. And so you can decide to choose your model, the model that you want to use to do your work, right? So different organizations are doing things differently now. So that's where we want to be. You want to think of your career path. You want to always think of your career path and make decisions around your career path. It's very important. And if you have any questions about that, please don't forget to reach out, because we're always ready to talk with you how. All right. GitHub Copilot. Yeah. GitHub Copilot that's a huge one, right? GitHub Copilot is huge. I'm using GitHub Copilot a lot in some of my projects, right? And it's amazing. It's amazing. Copilot now, it's integrated with Visual Studio. And imagine you're coding and you have an assistant right there telling you, hey, this function, already prompting you, like it's prompting you with already everything that you're writing. You don't need to go and the boilerplate tools, you begin to build them yourself. No. Who would have the time again to write a simple Python script to go and do this? No, you don't have the time. Punch it out and it gives you, just modify. You just need to know what you're doing. right? So it's a world now where you want to be in a smart space. You don't want to be in a in a traditional. You think that you just do it yourself. Work? No, 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 no. Right now, I have a paid subscription, and that's Kinesin. I have a paid subscription of GitHub Copilot for all my employees. Amazing. That's it. That's it right there. So you see, so many people already understand what this means and productivity. And right now, Kinesin is expecting productivity to be high for his employees. Why? Because they have assistants, they have tools at their disposal. They have things that they can use to 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 improve their performance. And he's expecting them to be performant. To if I expect you to write a program to me in 2 weeks, and you have Copilot, I'm bringing it down to 1 week, right? Because you have what it takes to be able to do that. And so we're getting to a place where I was listening to Elon Musk the other day, and he was saying uh, the, we are reaching a point where we work will be optional. That's what he said. He said we're reaching a point where work will be optional. Like he gave the example of you growing your garden at your backyard versus you going to the store to buy food or to buy anything that you have. Right? So you either choose to grow your garden and harvest your food, or you go to the store to buy food, which is ready made. And so he said, work in the next whatever number of years could be optional, right? So that everything would be done by robots, humanoids, and human beings can decide to just do it just because they want to do it. And he also said money will become valueless he's foreseeing that money will become valueless. Money will not have any value in the next generation, so in the next whatever years to come, right? Why? Because things machines and everything would be able to do everything, and the value of money will really. But he said that there are still things like uh, uh, the, um, the laws of physics that may still need a certain level of commodity that is traded to be able to get them, because they are scarce. They are scarce. Is what he said, and it's interesting. That's where the world is heading, right? And so you want to be in a space where you are able to make smart moves. Don't just put your head down and forget about whatever is happening in the world, because he will come and meet you with a firing letter or a letter telling you, hey, sorry, you've worked with us for 20 years, but sorry, we really appreciate the work you've done. But there are new ways we have to move. The organization is moving this other way, and we don't think your your whatever aligns with organizational. I hate to hear a letter like that, or to send a letter like that, but it's a letter that can come to anyone. And you want to position yourself to be in a place where that letter doesn't matter to you. And guys, that's why we're trying to build things. Let's build things. You can build things. Let's build things. Let's be in a situation where you are the one firing a company and not a company firing you. You should be in a position to fire a company, to tell them, hey, I'm getting out of here because I don't see you contributing to my growth. You should be able to move quickly and be an asset. Organizations are looking for assets. They don't hire you because they like your face. They like, like you are talking nicely. No, they want you to bring value. And what is the value you bring to an organization? You want to make them to make more money. If it's through coding, you have to be an expert in it. If it's through building tools and aligning systems, you have to be an expert in it. And so you have to be at the top of your game. And that's why learning is a big thing. And that's why we have Primus Learning, we have Skill Link, which is launching in the next 2 weeks, guys. We have a tool called Skill Link, which is coming up, and I trust you can be anywhere in the world and connect one-to-one with employers or with anybody and teach them whatever you know. That's what we're building. And you can make money from it. So any student anywhere in the world should be able to connect on a platform and learn from an expert in any field anywhere. So if I don't know anything in music, I can come to the platform and musicians can sign up and they teach me every hour hourly. And I pay them directly and I learn the skill from them. If you want to learn music production, if you want to learn coding, Python, if you want to learn anything, so we're launching in the next 2 weeks, guys. And so look out for it. And that's why I'm saying build tools, build things that contribute to society's connectivities, to society's growth, and so on, and you bring value, a lot of value. And as you're building, you're learning. As you're building, you are learning. Trust me, if you start building today and you build this today, tomorrow you say, no. This in 1 year, like 1 year from now, you say, oh no, what did I build like this? You've matured in the way you're building. You say, no, I needed to do this and this. And you already are increasing your features, the features of your tool or your whatever. You are improving on them. And next year, you're already in that mature state and you're already thinking the next big thing. That's how you do it, guys. And it's the same thing that applies to learning. I've been in the learning space for a long time, in the education space, and done different models in education. I've written a paper. I'll be publishing that paper on how improved learning and how AI models can help us learn, right? The different models that we can bring in AI that can help the learning process. So it's a learning, and I'm terming it. I'll not disclose it yet till I publish it, and it will be a framework, and the framework can be used to build in universities to build learning systems, right? And so I've been in this space, and you want to the more you learn, the more you unlearn. The more you learn, the more you unlearn. You unlearn those ideas, those things that keep you in one place. The more you learn, the more you unlearn yourself from bad ideas or ideas you thought were the best ideas. And you begin to bring yourself into new ideas, into new. There's no day that you connect to learn a new thing and you don't learn that new thing. Either you hear it today and it's somehow in your system, it affects the way your next move is going to be. So guys, and that's not a bad thing. So guys, let's keep working on these things. It's absolutely important. And that's why we have things like this, like you see, just like 5 people will be joining things like this because they are like, oh, that guy is coming and he's talking a lot of AI concepts. I'm bored. I don't feel like I can't do it. Those are the ideas in your mind. You're like, no, I can't do it, man. This AI thing is not for me. And tomorrow you just, oh no, this music thing is not for me. I can't do it. This coding thing is not for me. Those are the things that you want to unlearn. It is for you. It is, you can do it. If I can do it, if Kineson can do it, if Valentine can do it, you can do it. Why are you limiting yourself, right? There are a lot of people out there who are like, oh no, I can't, you know. As I was talking with the You Can Be Anything podcast, also shouting out to them. You guys can reach out to them. You There's nothing holding you back. Be at your summit there. Do that PhD if you're holding it out. Do it. If you're keeping, if you're, if you're afraid, if there's, you see that risk attitude is, it's absolutely important in decision making, guys. This is all about decision making, just as our topic was today. You have to know how to make decisions. And it goes like the same thing that we just saw, the decision theory. You have to learn where your risk attitude is and be able to model your decision making and inform your risk attitude. To be able to make decisions, you have to, you have to unlearn and learn new things. So it's absolutely, absolutely important, guys. All right. Thank you very much, Valentine, for joining. Appreciate it. And thanks everyone for joining. I think we'll end there for today. I didn't want to go above an hour, but we actually went above an hour. So today we basically looked at week 2, right? And week 2 decision making. There was still utility theory and the various utility models. I'll just touch this briefly next week and show you the demo, the interactive demo, and then we'll go to week 3. Week 3 will be big, guys. It will be all about natural language processing. We'll learn about natural language processing and how we can use that in processing information, right? And different things, and how AI systems use processing models. All right, thank you guys for joining. I really appreciate it. And talk to you again next week. Bye-bye. And don't forget to add your comments and questions so that we can tackle them next week.